Welcome to What the Fuck Do You Do? A show where we learn about various professions and what people actually do in their jobs. I'm your co-host, Shrey Panda,
And I'm your co-host, Travis Fox.
and today, the job we'll be talking about is a data scientist. Our guest today is Michael, who is currently a data scientist at a startup in Austin, Texas. He has 3 years of experience working as a data scientist, and we're excited to have him on the show. So, Michael, we interviewed a few people to see if they knew what a data scientist does. So, we wanted to play these to start and get your thoughts.
Okay. Let's hear it.
What does a data scientist do?
A data scientist, I have no idea, but I would imagine a data scientist, isn't that kind of like analytics where you're just reviewing numbers in like data mines?
A data scientist, like, I don't want to answer it. They analyze data.
Oh, extrapolate is such a good word. I wish I would have used extrapolate.
They extrapolate information from large data sets, and they're really good at VLOOKUPs. They're good at VLOOKUPs. They do a lot of VLOOKUPs.
The word in the definition, a data scientist
makes conclusions from information.
In the recording.
They analyze.
So, what did you think of those explanations?
I think they're great. I think that it's probably equally difficult for me to describe what I do. And I kind of like it that way. I think for me, I would describe data science or a data scientist as someone who uses data to solve business problems fundamentally. And that usually involves predictive models that help businesses figure out how to spend money, how to attract users, how to prevent users from leaving their company, any number of things.
That's great. And you mentioned a few different, cases of how you might solve problems, but I'm curious, like, what are some of the problems that you solve as a data scientist on a day-to-day basis?
The kinds of problems I'm solving, I've worked at I've had two different data science jobs. And the first one, we were mostly consultants where we offered a number of different solutions through a product that we had, but we were an early stage startup and our goal was the goal was really to win over these clients. And so the way we did that was by not necessarily rolling out a product that was really well developed. We kind of had to, act as a consultant. We had to solve whatever problem they wanted, which didn't necessarily fit into our product. But generally, the sorts of problems we were solving, they were propensity model type problems.
What is a propensity model?
Yeah. So what's the propensity that someone will buy this product? What's the propensity to leave and churn? I spent a lot of time on modeling what's the propensity that someone will buy a car in the next N days. And then also did what's the propensity that someone will churn within the next N days. So similar types of problems, but very different when it comes to how you use the predictions you get from those models, which I can touch on if y'all like. Now with my new job, it's very much a product company, and the problems I'm working on are how much to bid to buy internet traffic to come to our website. So we're bidding on ad space, and I'm trying to figure out how much to bid on each potential user coming to our site.
Gotcha. So what are the types of data that a data scientist typically looks at?
Yeah, it really varies quite a bit. I can tell you the data I'm working with now is related to mostly user demographics. So how old they are, if they are married, if they, what their credit score is, things like that, that we have access to and will have access to at the time we have to make our prediction to say how much is this potential user worth to us? How much are they going to spend on our website? One thing I like to think about when I'm solving a data science problem is, what are we ultimately, assuming we're trying to predict something. So I'd say most of the time in an applied data science role, you're building models under the branch of machine learning known as supervised learning, which is where you train your model on historical data in order to predict on new data points, unseen data points. So for example, in the case of the ad bidding, I would have a data set. You can think of it as an Excel spreadsheet where in the columns you have the age of someone, their marital status, whether they're insured or not, credit score, all of these things. And then you'll have one column that you're trying to figure out. And in your historical data, you're going to know that value for all of the users. So in the case of this problem I'm talking about, it would be how much revenue they generated for our company. And so when you're training these, it's a supervised learning problem because you're not just telling your model to like find insights, to mine, if you will, to mine insights in your data. You have a very specific goal. It is to predict one type of thing. In this case, it is how much revenue they will spend. And you have historical data to use to understand the relationship between how much someone spends and all of their other features.
And so when you find out an answer like that, or when you make a prediction based on the data that you're looking at, who do you tell within your company? Like, who do you actually work with to try to drive action from that sort of finding?
There are a lot of problems where you're not actually doing anything with the predictions, but you're training a model to understand the relationship between the thing you're trying to predict and the other features. It could be, and that's kind of like data analysis, where you're trying to say, what are the, I hate using this word, but what are the drivers for the thing we're trying to predict? And maybe you report that internally to some business folks, or maybe you give them predictions for them to act on. In our case, the company I'm working at, product company, once we are happy with these predictions, we would actually put the model into production. And what that means is once you've developed and tested it and proved that it's working the way you want, then you would expose that model to your live production environment where users are coming in. You're gathering their attributes and you're generating some sort of prediction that is being used in your product. Does that make sense?
Yeah, so it sounds like you are developing these models to understand the relationship between a lot of variables and whatever it is you're trying to predict. And once you have a model that has established that relationship, you can feed the model more data to generate more predictions.
Yeah, that's exactly right. So I think like the kind of classic example of how supervised learning works is you're trying to predict the price of a home. And, to start simple, you have the square footage of the house, and you're going to fit a linear regression model, which is just a line. So you have on your x-axis, you're going to have all these house sizes. And then on your y-axis, you have the price of the house. Well, you'd expect bigger houses are more expensive generally. So you're going to fit the best fit line you can to that data. And the slope of that line is essentially the relationship between the size of the house and the price. So that what that allows you to do is, one, you understand the relationship, you understand how connected those two things are. Like if the slope is 0, it's just a flat line, right? That means that no matter what the size of the house is, your price isn't changing at all. It's fixed. Your price is fixed. Whereas if you have a slope of 1 and you have to kind of standardize your data. But anyway, if you have a slope of 1, that means you have a really strong positive relationship where as the house size increases, so does the price. Once you have your line, then what it allows you to do is you get a new data point. And let's say the size of the house is 5,000 square feet, and nowhere in your historical data do you have that data point, well, that model allows you to put a price estimate on it, and that can help your business in some way. And if you think about the line, right, if you have data points all over, around like 0,000 to or 1,000 square feet to 3,000 square feet, and you have a 5,000 square foot house, the person we heard at the clip at the beginning of this, you are extrapolating out from that, right? You're understanding the relationship of your historical data so you can extrapolate out to predict that. You can imagine as you add more variables in, those are going to change your prediction in some way. And so your model says, okay, increase the price of the house by $10,000 for every square foot. The number of bedrooms in the house, increase it by $50,000 for each additional bedroom. So when you get that demographic data, this person's female, all that, you pass it into your model spits out a prediction based on their attributes.
That's really helpful. I feel like I actually understand that with that kind of like realistic example. I'm curious, like, what were the steps that you actually took to change your career and launch it in the data science world?
My background, I studied economics in school and started working in finance, and then started coding my first finance job and really liked it. So I started looking for other careers and got into data science. So it really, for me, I think of data science as mostly, you need to have business knowledge, you need to have software engineering knowledge, and you need to have that more scientific knowledge, the more theoretical. You need to be pretty good with math. And that was the weakest point for me, because I think the first thing I addressed when I was starting on this path was the software engineering stuff. I was learning how to code, all that. And then the business side from working in finance. And so I had to do a lot of work on the other side to be in a place where I could get a data science job.
So given that this requires a lot of technical knowledge, do you have to have some natural skills or abilities in order to become a data scientist?
I don't know. I do think it's probably more demanding intellectually than other jobs. I think you have to be really comfortable with stretching yourself, and there are no autopilot days in data science, which I love, but that I think that could turn some people off to it is there aren't you don't have every 2 weeks I have to produce this report and it's going to take me this amount of time. Every day is different. And I think you do have to want to stretch yourself. I think that most people can probably do it if they have the right attitude. I definitely think there's so many great resources online to learn for free or basically free. Like that engineering course you can take for free, or you can get a certificate for $50. So it's definitely, you can definitely get all of the skills you need for very cheap. But that doesn't mean that even if you have all of the skills, your resume will look good enough on paper to get an interview. I think that could be tough.
So having the credentials and resume are essential in getting an interview, or not so much, and you could potentially demonstrate all the necessary skills in an interview?
I think that you could demonstrate it all in an interview. I just don't think you could get that interview without knowing someone, which is often the case when it comes to getting interviews. It's really hard without knowing someone. But I'm certainly not in the position where I can apply online and do a cold application and get responses. That doesn't happen. I imagine there are some folks who have PhDs and really impressive backgrounds who, they do get hits. They get all sorts of LinkedIn attention, which is, I don't have an issue with. A PhD is a huge time commitment, and I think it's really impressive to follow through.
Where do you go from here? what is career advancement as a data scientist, and where might you end up after a decade, 2 decades of working in this field?
Yeah. Well, I don't think I know what it'll look like in a decade or 2 decades, because it's such a young field that I think it's due to have, I think there's going to be a lot of changing with what data science means and what data scientists do. Right now, I think it's similar to engineering in that you kind of have a individual contributor growth path, and you have a management path where, you know, you can get into become a data science manager, director, VP, and then chief data scientist, chief data officer, chief CTO, whatever. But the management path, and then there's the path of individual contributor who's leading initiatives, is probably mentoring people, but isn't directly managing them, is still coding themselves, is getting to work on the like really challenging data science problems, and is setting the company's what's the word? I guess roadmap. I don't like using business jargon, but you're setting the roadmap with respect to what your data science group is going to do. And so those people are called like principal data scientists, and you'll have like some people call them fellows. Like once you're just a boss individual contributor, you're a fellow, which I think is pretty cool.
I have a question for you. It's something that we're hoping to ask our listeners and the guests on the show is, you know, we've now learned a lot about data science, but there's a ton of other careers and professions out there we still know nothing about. What job or career are you curious about? What would you like to learn more about through the show?
I'd go for something unconventional, I think, like maybe a chef. I love food, and I feel like that job has a lot of different demands, but yeah.
Well, Michael, thank you so much for joining us on the first episode of Under the Hood. You were a fantastic inaugural guest, and we appreciate all of your insights.
Thanks, boys. It was an honor.
Thanks again for joining us on What the Fuck Do You Do with Travis Fox and Shrey Panda. If you enjoyed listening, please make sure to subscribe to us so you don't miss out on future episodes. And if you're interested in a job that you're curious about being featured on the show, check the link in the description and let us know. If you liked this episode, we hope you subscribe to us on YouTube and Spotify and share the show with your friends. We really appreciate your support.